Hello, my name is Ozlem Polat, and today I will be presenting my research on the evolution of software architecture patterns. Software architecture patterns are essential blueprints for structuring software systems. These patterns provide solutions to common design problems, ensuring system efficiency and scalability. This research explores various software architecture types and patterns, highlighting their significance in system design. The focus is on the top 5 architectural patterns and their key characteristics, while excluding detailed implementation specifics. Software patterns improve solution efficiency and organization. Different patterns such as monolithic and microservices offer distinct advantages and challenges. Integration of these patterns is crucial for maintaining system sustainability, and studies emphasize the need for continuous evaluation and adaptation of architectural patterns. Careful consideration must be given to selecting the right pattern based on specific project requirements and constraints. Key characteristics to consider include scalability, modularity, flexibility, maintainability, and performance. The continuous evaluation of architectural patterns is fascinating. From the simplicity of layered architecture to the complexity of microservices, each pattern addresses different needs and challenges. The dynamic nature of software development ensures that new patterns will continue to emerge, shaping the future of software architecture. Now let's move on to the main part of my research, the timeline of architectural patterns. Starting with monolithic architecture, in the 1960s, the monolithic architecture was predominant. It integrates all components of the system into a single, self-contained unit. This approach simplifies the development and deployment, providing better performance for small to medium-sized applications. However, it can be difficult to scale horizontally and may lead to an unwieldy large code base. Monolithic architecture is typically used in small to medium-sized applications or when resources are limited. In the 1970s, the microkernel architecture became popular. This pattern emphasizes separating core system functionality into a small microkernel, extending functionality into plugins. It enhances system flexibility and improves fault isolation. On the downside, it can introduce performance overhead and increase complexity in communication between components. This architecture is often used in operating systems, embedded systems, and applications requiring high modularity. Now, let's look at layered architecture. In the 1980s, the layered architecture was widely adopted. It organizes the system into layers, enhancing modularity and maintainability. This approach simplifies debugging and maintenance, but can introduce latency and complexity in interlayer communication. Layered architecture is commonly used in applications requiring layered separation, like enterprise applications. In the 2000s, the event-driven architecture gained traction. This pattern uses events to trigger actions within the system. It's highly decoupled, scalable, and responsive. However, this can be difficult to debug and handle complex events. Event-driven architecture is used in real-time applications and systems with asynchronous processes. And finally, microservices architecture. In the 2010s, the microservices architecture became the norm. This pattern composes the system as a collection of loosely coupled services. It enhances scalability and maintainability, allowing independent deployment. However, it can lead to complexity in management and deployment. Microservices architecture is suitable for large-scale applications needing continuous deployment. My research on software architecture patterns has shown how these patterns evolve to address the growing complexity and requirements of software systems. Understanding these patterns and their historical context help us appreciate the solutions they offer and their impact on modern software development. Thank you for watching.